Um, okay, it says I'm recording, so I think we're good to go. So thank you very much for coming. What I'd like to do today is show everyone where we're at with Habitat for Windows. Let's see, I'm gonna, oops, can't minimize. Here, I'm gonna go ahead and share my screen because I actually don't have a deck prepared, so this is very exciting. This is going to be pretty much demo only. But before I get started, I'm curious, who here hasn't even heard of Habitat? Like has okay, awesome, cool. So we got one person. And then who here has actually played with Habitat? All right, great. So we have a good spectrum here. So let me start off by giving you my rendition of what Habitat is. So Habitat is basically Chef's newest product. It was launched, I believe, April of last year, and basically Habitat is attempting to come at automation from a different direction than the Chef client. So while the Chef client focuses on automating your infrastructure, Habitat really focuses on automating the application itself. And in doing that, it strives to basically keep the automation and the application together. So it really looks at the person deploying the application and tries to make that whole story come together for what we call a modern application. What is a modern application? Different people have different definitions for that. We'll just say it. Chef is really, or Habitat is trying to solve problems in application automation for any application, but we're really targeting problems specific to distributed applications. So in today's world, it's a lot more than just getting your code or getting your compiled bits onto some individual node. It's much bigger than that, right? So an application is really more than an application. It's a stack, and so you might have your application behind your web nodes, as well as applications for middleware services, other HA proxy databases, queuing, whatnot, and even in those individual servers or services, you'll have multiple of them. So we've got replication, we've got mirroring. It's a very complicated world that we're deploying to these days. And Habitat is its aim is to simplify and streamline that process so that you can do that deployment on any platform and in any environment, whether that be containers, VMs, or bare metal. So we'll in the end, the best way for me to tell you about Habitat is to actually show you Habitat. So I'm going to show you today Habitat working on Windows. When Habitat was launched, and ever since its launch, Habitat has worked and does work on Linux. It works great on Linux. But since day one, I believe our message has been that we want it to work on Windows. We want it to work, not just Windows, but across several different platforms. But right now, we're focusing on Windows, and I've been on the team since October. I've been working with teammates like Steve Murawski and others on the Habitat team, and my focus has really been to make Habitat work on Windows. We've come a long way. We've come a long way further than what you see today when you release or when you download a Habitat release. So I want to show you here basically everything that we have. A couple caveats to keep in mind is that what I'm going to show you, a lot of it you can't do with the current released Habitat today. So some of the features are dark. You can get to by turning on certain flags. And then some of the features are, I'm actually working with a Habitat executable that's somewhat hacked. It's not very hacked. I mean, I'm honestly talking about like 4 or 5 lines of code. But one of the biggest issues with Habitat today is depot integration. So I have a Habitat executable that basically tells the depot what you're going to call this file is the Windows version of the file, and I'm going to be hitting a particular depot, not the public depot, that only has Windows packages. But keep in mind, everything that I'm showing you is other than those 4 lines of hackery, is actually in the released product today. So let's get started. So the first thing I want to show you, I'm actually going to let me switch displays if I can. Let me show you what a habitat plan looks like on Windows. So again, a habitat plan is basically the piece of source code that builds the artifact that Habitat will deploy and actually run. And so Habitat is many things. It has a build element, so you build a plan. It pumps out an artifact. It's called what we call a heart file, a Habitat artifact, and then it has a runtime, what we call the supervisor, and that artifact gets deployed to a supervisor, which is where it's run. So let's look at how that looks like in the Windows world. If I was showing you this for Linux, I'd be showing you a bash file, and anybody here that's played with Habitat has probably seen those files. And this file probably looks very, very similar, almost identical to the files that you've seen, with the difference that this is PowerShell, this is not bash. So there's just a couple, really syntactical differences here. You see $signs in front of the initial variable declarations. This array looks a little different. This is a PowerShell hash table, so this will look a little different. All of our functions actually have the keyword function in front of them, and we actually give them kind of a PowerShell-y name, invoke-install rather than do _ install. So let's dive a little bit into this. So the demo that I'm going to be showing that this is going to build, along with some other services, is going to be an ASP.NET core MVC applications, and hitting a MySQL database, MySQL running on Windows, load balanced with HA proxy on Linux. So that's another thing. So a lot of people that are running Windows, anybody here is running Windows, what you may be in an environment where you're not only running Windows, you're running Windows and Linux. And because the Habitat supervisor speaks a protocol, we call it the butterfly protocol. So it's a gossip-based protocol by which Habitat services can talk to one another. As long as you can talk that protocol from one operating system to another, you can work inside of a single Habitat ring. And I'll get into later what a Habitat ring is. But right now, let's take a quick look at this plan. So we've got some basic metadata here where we're saying that the name of this plan is MySQL. Actually, you know what? I didn't realize. Let me show you. So this, for those that are curious, this is the plan that creates MySQL on Windows. And really, all this does is this just downloads MySQL, downloads the binary, and stuffs them into the heart file. So actually, I'll stay here for a moment. So key things here is it unpacks this zip file. Because there's really no building per se that's happening. I'm not doing like a make here. I'm not building a C++ program. We've just chosen to download the bits. And then in the install, what I'm doing is I'm taking what I'm downloading and I'm laying it out in a structure that right after this invoke install runs, the packaging system will take that and package that, compress it and archive it up into a single file, a heart file. And that single file will contain all of the MySQL binaries that I've copied into this little scratch space over here. Another thing that's key here is this exports. And when we get to talking about how do different Habitat services share configuration, you'll see where this is important. I'm actually going to come back to this after we've started the services, and I'll illustrate how this works. But for now, you can think of this section as basically defining a public configuration interface, where this plan, this MySQL plan, is basically publicly declaring this is the bit of configuration that I am exposing. I am exposing, and on the left-hand side, it's this is the external, how it's being exposed externally. Again, we'll get into this in more nitty-gritty details later. So the left-hand side is how it's being exposed externally, and the right-hand side is how it sees it internally. So each plan, many plans have this file called default.toml, and so here in its default.toml, those right-hand side tokens, you can see them here. So by default, now we can inject different configuration in, but by default, it's going to use HAB as the username and password for the database that the initial MySQL setup will create. But let's take a look at our .NET application. So in this particular repo mostly composes that application. So if anybody here is familiar at all with .NET MVC, you'll notice the familiar folders, models, controllers, views. That's actually not all that interesting here. Just know that it's a standard .NET core application. What I am going to zoom in is the actual Habitat folder. So I have a Habitat folder inside my application, and this Habitat folder has the plan and initial configuration. So here's the plan for my .NET app. And first of all, just real quick, anybody here .NET developers or familiar with .NET? Okay, cool. So a lot of people new to this space. So the thing to keep in mind is here in the build, I actually am building an application. But I'm building this application as a normal .NET Core developer would do. I'm not introducing really any new concepts into the build itself. So a .NET Core developer would know that he or she needs to run .NET Restore, which is basically going to go off to a NuGet repository. You can in the .NET world, NuGet is basically like Ruby, what Ruby gems is to Ruby, or NPM is to Node. So I'm going to go off to my NuGet repository and grab all the packages that I need to build this app. I know what those packages are because it looks inside. So if you're a .NET developer, you know that the csproj file basically defines what those are. So it's going to go off to NuGet and get these packages. And then it's going to, let me see, just 1 second. Okay, sorry about that. And so then it's gonna do the build. It's gonna do a .NET Restore gets the packages. .NET Build is actually gonna build my code. And then in the invoke install, which is where it basically lays out the file, it's actually quite simple. I simply do a .NET Publish and give it the output directory. And what .NET Publish does is it basically knows, okay, in order to run this app, these are all the files that you're going to need to make up the runtime and to make up your application. You're just going to dump them into in this www file. And then what happens, the Habitat build system will take everything inside a package prefix and compress that and archive it up into the final heart file, which I'm about to run inside of a supervisor. And again, you'll see here I'm exporting some bit of metadata about myself, which is the port. The reason why this is important, this is going to become important to HA Proxy, because HA Proxy is going to load balance 3 separate services running the same application, and it's going to need to know what port those are running on in order to expose them through the load balancer. So that's just a little bit of background on the build system. Let's actually get to running this. So here actually real quick before we run it, let's actually build it. So so here I am. I'm actually in the root of this repository. And by the way, if anybody is interested in looking at this code, this is all on GitHub. It's in the habitat-sh org. It's a repository called exactly this, habitat-ASP.NET-sample. If you want to look at this. So I'm gonna go into a Windows Habitat Studio. So I'm gonna type Hab Studio. Oops, not run. Enter. And so what's happening now, so for those that have played with Habitat on Linux, you may be familiar with the concept of a studio. A studio is basically what we call a clean room environment. So we try to make the studio as free of environmental side effects as we possibly can. And so what's different about the studio environment from the PowerShell environment that I was just in is, one, I'm now in PowerShell Core. I'm in a known version of PowerShell Core. The one reason why that's important is because I know the version of PowerShell that I'm in. I know the commandlets. I know that some of the nuances that I can expect from PowerShell, and therefore, as a planned developer, I know that I can target PowerShell Core. As long as I target PowerShell Core as opposed to some specific version of PowerShell that comes on any given version of Windows. So if I'm just, it's difficult if I design for PowerShell 2, which comes with Windows 2008 R2, because that's going to be completely different PowerShell than what ships with Windows Server 2016. This version of PowerShell can run on any of those operating systems, but has a known set of commandlets. So I'm inside of that version of PowerShell. I have a cleaned up path. So normally my path is pretty huge because I've installed a whole bunch of stuff on this laptop. So this path just has C Windows System 32, and the HAB executable, really. Then, as I'm doing a build, so one thing that's interesting to show is as I'm doing a build, there might be other stuff that the build system will add to my path. So, for example, in my ASP.NET application, when I'm building this application, I'm taking a dependency on the actual .NET Core runtime. So there is a package for .NET Core. And so the reason why that's important is it's going to put this dependency, it's going to put it in the path. And what that means is that I can now have these commands inside of this plan, this .NET plan. So this is a .NET executable that I may not have in C program files, but because the build system sees that I have a dependency and will therefore put the artifacts of the .NET Core package into my path, I know with confidence I can call .NET this .NET command and know that I have access to it. Another thing that we've done is we've actually packaged up the Visual Studio build tool, and that's a pretty. I'll show you that one real quick. So this one in the Visual Studio build tools, that adds a whole bunch of stuff to the bin, to the lib environment variable, to the include environment variable. So now I can actually build. With this, I can actually build native Windows apps, and it'll properly link to basically Windows SDK bits and be able to build those native apps. We're not going to be doing that today though here. So let me go ahead and build that. So yeah, it's very similar to a Linux Studio. I'm just going to type build. And here I'm just going to type dot. Well, here, let me just build this first. So there it goes to build it. This looks not too different from what we're used to in Linux. It's pulled down its dependency core, the core .NET Core package. It's doing a .NET restore, like it's just built successfully. Probably doing its publish now. Okay, now it's at the end. The build is done, and now it's actually it's compressing everything, and it's going to generate that final heart file. So that's what building looks like. The one thing I also neglected to say about the clean room, we create what's called a PowerShell drive, and what that does is that basically roots your file system. So if I do a ls/ here, I just see HAB, which has all of everything that Habitat expects to be on disk just for Habitat to run, and source. And source is basically a symlink of this directory here. Basically we symlink the directory that you came from. So if I exit out of this, you'll see I came from the habitat-ASP.sample directory. So we symlink that directory into the source directory inside the build system. And now I am in my normal PowerShell environment. You can build inside of the normal PowerShell environment, but there's more guarantees if you build inside the studio that things will play nicely. So let's actually now get to running these services. So here I have 6 different console windows, and these comprise 5 different VMs. So I'm going to have, in this one, I'll start here, and I'm going to start up MySQL. So basically what I've done is I've called HabStart, and that starts up the supervisor. The supervisor is the Habitat component that actually runs our app. And so actually one key thing that I didn't show you that I should show you right now is, so how do you actually run, how does a supervisor know how to run our app? Because obviously if I want to invoke a Node app as opposed to a .NET app, as opposed to a Ruby app, like that all works totally differently, right? So that works through hooks. And again, if you're familiar with Habitat on Linux, you know what hooks are. The key difference on Windows is the hooks, again, are PowerShell. And so here is the PowerShell hook that runs my application. So I have, you'll notice some of these brackets. This is handlebars templating. So we use the same templating that we expose in Linux Habitat. But what's being templated instead of a bash file or a bash script is a PowerShell script. So this is going to cd into basically the service directory that the Habitat runtime supervisor works out of. It's going to set a certain environment variable that's going to help the configuration file be found in the right place, and then it's going to call again the .NET CLI. And this time it actually calls it with a DLL. So this DLL, which is basically a .NET binary that's been built. When you build a .NET library or a .NET web application, the outcome, the output file is a DLL file. Now this is the DLL file that is my application. And so when I call .NET and point it to my DLL, it's basically it's going to run that DLL. And the results, if I can switch desktops correctly, is going to be down here when I actually go to run my ASP.NET file. So I have a database running, as we just did. Now let's start the ASP.NET core app. And so here's something interesting. It didn't actually run that hook, and there's a reason for that. If you look at the yellow text here, it says election in progress. And then I'll scroll over. It says, and we have no quorum. So let's take a look at the command line that I actually use to expand this out a bit so I can the whole thing. There we go. So, so let's take a look at this. So we called HabStart, which, as we said before, invokes the supervisor. We give it the name of our service, which is Habitat-ASP.NET-sample. That's the name that I gave it inside of my plan. We give it a group. So inside of Habitat, you have what's called service groups, which is basically, you can think of service groups as a way of scoping the Habitat ring, which I'm about to define for you. But basically, it's a way of creating a scoping inside of a Habitat ring wherein you can share both configuration and you can share topology. I'll get into ring and topology right now. So what is a ring? So a ring is basically a group of essentially 2 or more service members. When I started up the MySQL, it was just a standalone service. It was the only thing, I had a supervisor running MySQL. It wasn't talking to anybody. Now what I have is I've given it this parameter called peer and an IP address. This could be an IP or a DNS name. But basically, if I want my service to talk to other people inside of Habitat, well, Actually, I really don't want to talk to other people. I want to talk to other VMs. But in order for it to be a peer, for it to talk to other services, I need to give it at least one other member of the Habitat ring. At least one other, the IP of at least one other service that's running. And you know what? It makes absolutely no difference which peer that is. It could be any machine running on it. But once I give it this IP, it binds to that IP, becomes its peers, which basically means the peers of that IP becomes its peers, and so on and so on and so on, until eventually you build this ring of connected peers. So as I briefly mentioned before, Habitat is using a protocol, a gossip-based protocol underneath the covers. It's basically taking a protocol called the SWIM protocol, and it's a slight deviation of that we call the butterfly protocol. And essentially what's happening is as we're starting up services, those services are entering into the ring saying, hey, I'm alive, and they're saying that to their peers, which is, when I say that, I mean basically one or two members of the ring. So let's say if theoretically I had 20 members in this ring, I'm not going to say that to all of the members. I might say that to the two or three people, in the ring at random. And then what then happens is those people are going to gossip that information and we call them rumors. So it's going to gossip those rumors of my existence to a small finite number of their peers. And eventually the rumor that I exist will spread itself throughout the entire ring, and everyone will become aware of my existence in the ring, as well as my death. So if I'm taken from the ring, if this server gets killed, eventually, so what happens is when I enter into the ring, approximately every second, a peer is pinging a certain random number of peers. If they don't get a response back from a peer, what they do is they basically make a note of that, and then they contact other peers saying, hey, you know what? I haven't heard from this guy. Maybe you've heard from him. Can you ping him? And if they ping him and they get a response successfully, then it's like, then I'm confirmed alive and everything's cool. But eventually, if nobody does hear from me, I'm marked as dead. So that's loosely how the protocol works. If you really want the nitty-gritty details, check out the Habitat site, and we have all sorts of we actually give you links to the papers, or we also have like a high-level view as well. So the next key step. So I'm in a ring with one peer now. So there's two of us in here. But why does it just say election in progress? So the reason for that is because when I started the service, I gave it a topology, and the topology I gave it as the last parameter here is leader. In Habitat, there's two different types of possible topologies. The default topology, so if I would have said nothing, it would have been the standalone topology, which basically just says I'm standing alone, I'm acting as myself, and if that was the case, I would have started right up. But because I am in the leader topology, what that means is I have to have quorum before I can start. And in short, what that means in Habitat talk is there has to be at least 3 of me. And the reason for that is in a leader topology, a leader is chosen. So one leader is chosen. So as new services are entering into the ring, they're rumoring about themselves, and after enough services come in, we have enough members to elect a leader, and there has to be at least 3 services to elect a leader. So let me go ahead and start the other 3. Just a second, and I expect to get the exact same output from this. Now you'll see something interesting happen. Don't worry about the red. You'll see something interesting happen when this guy comes in. So you'll see now the other services are starting to do things, and you'll see application started, press Control-C to shut down. That's basically just the stock .NET Core output you get when you actually run a .NET service. So now I actually have these services running. And one final thing I want to talk about in the line that I put in to start these services is let's see, where is it? It's the bind parameter. So we talked earlier about how does one service consume configuration from another service, and we do that with the bind parameter. So, for instance, my ASP.NET application has absolutely no awareness of the IP in the plan itself and in the bits that I put in the source code. There is no awareness of the IP address of the MySQL database it will talk to, no awareness of its port, of the username and password. As we saw earlier, all of that information was actually in the MySQL plan. MySQL owns and is the provider of that configuration. My ASP.NET application is the consumer of that. And so what he's saying in this bind parameter is, I want to create an alias, a bind alias called database, and I'm going to bind that alias to the MySQL service in the dev service group. So I could have pointed to a different service group. I could have had a service group for production. Here, just for simplicity, I created a service group for dev. I could actually not specify a service group at all, and we create one for you called default if that's the case. But now I can look back to my templating, and we can kind of see how that gets wired up. So in my ASP.NET application, I have this asp.settings.json file. And this is basically in the .NET Core land, this is your settings configuration file that .NET knows to go and look for. And one of the settings in here is default connection. This is basically the database connection string. And you can see that templating that we looked at before, I've got bind.database.members. So what that's saying is I expect to be bound to an alias called database. Now, there could potentially be many members, and when we get to HA proxy, we'll see a scenario where there are. There's only one database, so I'm just going to get, it puts them all in an array. I expect just one member, so I just do members bracket 0. So give me its IP. The IP we actually get for free in Habitat, but under the sys namespace. Then give me its UID. So this was one of the keys that we exported in the MySQL plan, as well as its password, PWD, and port. So this is how it knows dynamically at runtime how to hook up with the database. And then just to show you all that I'm not, this isn't a total farce. I'll just refresh this page. This is what's from before. But I'm going to refresh this page, and I'm going to expect it to, for the spinning wheel to stop, and it to actually, yeah, here we go. So this is real life, and this is pretty much as simple of an application as you can get. You basically create messages and view messages. Let's create a new message. Let's see. We'll call it new message. There, oh yeah, our new message. So let's load balance these. So I'm hitting an individual one that just happens to be off of 202. They're all listening off of port 8090. But having 3 web servers doesn't do me a whole lot of good if I have to go to each one individually. So let's fire up our HA proxy plan. So I have over here. So this is I'm SSH to this box, and not these other ones. I was using PowerShell remoting. Now I'm using SSH. Start that guy up, and he's just a simple standalone one. In this scenario, I just using a single HA proxy. And let's look real quick before we actually open that, hit him on the web. Let's look at his configuration. It's kind of a little more interesting. So here's our HA proxy configuration in Habitat, and the key thing to notice here really is this right here that I've selected. So basically, what this is saying is that if you're bound to a backend, and just for reference, let me skip on over to the plan for our ASP.NET application. And, oh wait, sorry, let me go back a second. So here where I started the service, here the bind that I gave it, the back end was the alias. So I'm saying alias, use the back end as my configuration alias, pointing to the habitat-ASP.NET-sample service. So if there's an ASP.NET-sample service out there in the ring, it's going to bind that to the back end alias. And we'll go, so going back to our template. So if they're actually, if you have a back end, so if there is such a service out there, so it's possible that I didn't actually start my ASP.NET services yet. In that case, this would be false. But it's not. It's true. So if you have a back end, for each, you can iterate each of the members. So I'm not just going to go into the 0th one. I want to iterate over all of them. But I want to have this restraint which says only iterate them and only include them if they're alive. So it's possible, I could shoot one of these servers and bring it down. And eventually, like I mentioned before, it will basically, people will other peers in the ring will be pinging it to see if it's alive. Those pings won't come back. Those peers will ask their peers, hey, can you ping this guy? He seems to be, he's not alive to me. They'll ping me, and I still won't come back. And they'll say, nope, he's dead. And so then I will not be included in if alive. So if alive will only include actually members within the ring that are gossiping information about themselves actively. So for each of those members, it's going to pull their IP address and the port that they're running on. And if you remember, we get the IP address for free in this sys namespace, and the port, that was one of the configuration settings that I exported in my ASP.NET application. So now what we can do is I can go, instead of going individually under port 8090, is I can go, so this is the actual IP address of HA Proxy. HA Proxy is listening off of port 8080, and I would expect this to come back successfully. And the reason why that takes a while is, like a lot of different run times, the very first time you hit an application, it has to, start itself up and do a bunch of initiation. And this is round robining across all the different servers. So it's likely different than server 202. But I could actually look here. So here is, I'm going to bring up the HA Proxy stats endpoint. So let me refresh this. And so this is what HA Proxy knows to be the state of the world. And I can see down here, you could probably barely see this if at all, but basically, I'm telling you that these are the 3 IP addresses of my ASP.NET application. And so the beauty of this is that in Chef, I would have to write all sorts of code to do a Chef search, to search, for, maybe nodes that have a particular, recipe that deploys my ASP.NET app, and then I collect what all the IP addresses are of that node, and then I dynamically create this template configuration file. I can get rid of all of that code, and now, not only is it a one-time thing when a node converges, but actually dynamically in real time, as I add the ASP.NET services or remove ASP.NET services, this will basically true itself up in real time. So that is pretty cool, as it binds its configuration dynamically to the configuration of other services. A couple other quick things to show. Wrapping up here, but one thing I want to show you is updating. So what we can do in Habitat is we can deploy an application, and then what we may want to do is we may actually want to have that application update itself. So let's say I've done some work to my ASP.NET application. I've changed it, and I now want to have it automatically update itself. Now, first of all, the default setting is not to have applications automatically update themselves. So I have to tell it that I want to do that. And I've done just that, If we look at the command line, the had start command line, one of the things that I gave it was, here we go, strategy rolling. That strategy is basically an update strategy. So by default, there is no update strategy. Or it could be at once, which means as soon as it finds a new version of my application in the depot, it'll update itself. Or rolling, which means if I'm in this leader topology, so I have 3 services, 1 leader, 2 followers. I also have what's called an update leader. And that update leader will always be different from the actual primary leader of the topology group. And what that leader is in charge of is it's in charge of looking at the depot and looking for new versions. Now, in a production scenario, what you would do, you would subscribe to a depot and you would subscribe to a particular channel of that depot. So I might have a dev channel, staging channel, a prod channel. So once a particular heart file for my application is blessed and it's good and it's ready to go out to production, I would deploy and upload that heart file to my production channel. And then I would have, then if I started the service listening and subscribing to that channel. So here I have this URL. This is basically the URL of the depot. I'm not going directly to a channel. I'm just going, this depot is channelless. So you can we have the concept of channels in Habitat. So just to dispel the fear of, oh my God, I just I'm Joe developer, I uploaded a new heart file and now my production is going to update itself. We have a means of controlling the flow, controlling the pipeline from dev to production. But what rolling does is that makes sure that if I have multiple services, that they don't all update themselves at the same time. Because what happens often, if they update themselves at the same time, they're all going to get restarted at the same time. If they all get restarted at the same time, they're all going to stop at the same time, and then we're all going to have downtime at the same time, basically. And there's no good time for downtime. So let's actually do that real quick. Let's actually build something new. Actually, you know what? I already did that, as a matter of fact. When I did that build before, that created effectively a new release. So actually, you know what? Let's make it look a little bit different, just so that we know I'm not totally lying here. Actually, I'm not lying at all. But let's see. Let's go to one of the views. I'll go to the index view, and I'll just say new stuff. Save that. Whoops. All right, so go back to my studio. Build that. And while that's going, we'll get the upload ready. Okay. All right. So my heart file. Okay, it's working on it. Oh, here we go. So here's my new heart file. Grab that guy. Bam. Come here. I'm going to paste this in. So I'm basically doing a HAB package upload. I'm uploading to this depot. Steve Morawski set up this depot. So there's only Windows stuff in this depot, and this is the same depot that these guys are subscribed to. So I'm going to upload that. I'm going to upload that guy. And after that gets uploaded, basically what's happening here is this could be anywhere from 1 second to a minute. So every minute, the update leader is polling the depot for new packages. And so any second now, he's going to find that there's a package with a release number that's greater than the package that it's running. And when he finds that, you're going to see one of these guys start to move. But you should only see one of them move. Oh, here we go. So this guy is clearly must be the update leader. And he is down, so he's downloading it. He's now installing the new version, stopping. Now he's starting himself. Okay, now you're seeing this guy do it. And shortly thereafter, you should see this one do it as well. It's a little, yeah, so this is one of the rough edges we have to clean up. It's a little bit of a bumpy ride. Like for example, I'm not really sure why they shut themselves down and start themselves up sometimes 2 or 3 times. That's something to look at, but we should see this all. This guy.
Now, Matt, do you know if you query like the collaboration guide, like you can data about the status?
It does, and we'll actually. Oh, there we go. Yeah, so this is one of the beauties of. I'm just using the native PowerShell shell, and if you click inside of it, it'll freeze the output. That's what I have. Yes, I'll show that in just a bit. That's actually a great point. So now let's go back to our actual web. Oh, yeah, it drives me crazy sometimes. Here we are. So here it says index new, so now it should say index new stuff. Please. Still spinning. Okay, yeah, new stuff. So I've got my new version, and none of them, we didn't have a situation where they were all dead at the same time. And if all else fails, hey, I do have HA proxy to protect me. I don't have it fully configured doing health checks and all that, but conceivably you could. But so, to respond to your question, there are endpoints. So again, all I have to do is I just have to use it doesn't matter, any IP address from anybody in the ring. I should be able to get the information I need. So I'm going to do that. Actually, let me I just have to give it the, what is the port? It says it up here. It is port 9631. That's what I want. Port 9631. And there's a few different endpoints that we have. Let's go to this one first, Butterfly. So here, basically, we should see all of our, everybody that's in the ring, and we're going to see basically all of the we will see configuration. So here, this is one of the ASP.NET apps. We see it's exposing this configuration of 8090. This is the host name that it's on. These are the different ports that it's using. Its IP address. The first one is, here's HA proxy. So its configuration is it's running off of port 8080. The status port is 9000. That's the port I would hit to see this, basically. Another endpoint that we have, there's several. In the docs, you could look them up, but just to show you another one. So this one, no, I did not spell that right. So census, so this gives me some interesting information on like the leader and follower. This guy is HA proxy. So HA proxy I didn't put into a leader topology, so all this stuff is coming back as null. But if I look at one of the ASP.NET guys, this one, so here I've got, so this one is not the leader. He's a follower. He is the update leader. He's not the update follower. And he's alive. Suspect would be true if one person had pinged him and didn't get a response and was waiting on responses from other people to see if he was truly dead. If he was truly dead, then confirmed would be true. Confirmed is basically confirmed dead. So that's the metadata that we get. So that's really everything I think I have to show here. I think this touches on everything that we've done so far. So that being the case, so what is next with Windows? So things are a little rough around the edges. So we have to tighten up some things. We have to get that depot integration working. That's super key. Some things to do next are working with containers. So clearly, before we can get the Windows Container Story up and running, we have to make sure the thing that's running inside of the container is working. Once we get that far, we can actually start exporting Windows heart files to Windows containers. So that should be pretty awesome. Because it would be great if I could show you this demo without having to start up 4 VMs on my laptop, as well as everything else that containers are good for. So it would just be it'll be a great story for creating and running containers on Windows. The other thing is what I've showed you is a very happy path in terms of the flavor of applications. So we chose .NET Core. The .NET Core is very habitat friendly. The .NET Core is basically Microsoft's new the newer version of .NET that is much more portable and therefore much more easy to create an actual package for. But we absolutely want to target things like the full framework applications. We have some ideas. I'm not going to talk about that now, but we have ideas of how we can make that happen and make it happen quickly. And how we can get this working with things like IIS, get it working with things like SQL Server. Those are all things that we're very, very keen on doing because we know that there's a lot of applications in the wild that are using those technologies. Being able to work with native applications. I showed you the Visual Studio build plan. So that's one step to getting this to be able to compile any native applications. So for example, like if I wanted to build zlib for Windows, that's a step in that direction. But we need to start building packages for Perl and Python and get all that. And there's just a lot of like kind of ground level, low level packages we need to create for Windows to make that whole native story work for most of your common native libraries. So that's where we're at. And thank you, so much for checking this out. Does anybody have? I'm happy to take questions. Yeah. Oh, I see what you're saying. Like, rather than just getting like a snapshot of the current point in time. I don't. So I don't think so. I don't. I could be wrong. I don't. I think it's just.
What are you really like looking out for, like for
the main thing that we're the main thing that we're getting from PowerShell Core is basically a known version of PowerShell. Because if we're just saying, hey, we're going to use whatever version of so every modern Windows version comes with a running version of PowerShell. If we just said, well, we'll just use that native version of PowerShell, it would be very hard for us to standardize on plan syntax. And so by saying, we support this specific version of Core, which we know we can create. So we actually have a plan for PowerShell, and that's how we make sure that that's run. When you enter into the studio, we'll pull down the PowerShell plan from the depot and run that. Same thing actually that happens with the supervisor. When the supervisor runs your hooks, there's a guarantee that those hooks are going to be run inside of that PowerShell Core version. So that way we can standardize on the syntax that you'll use in your hooks and in your plans. Because especially like if you're talking between, say, PowerShell version 2 and PowerShell version 5, there could be some very, very fundamental differences.
Well, they're put in your depths, right? Like, so typically, say you assume there's a half package, whatever newer version of PowerShell or project are.
Yes and no. So the problem with so the other reason why we do PowerShell Core is the fact that we can build it. So with PowerShell 2, PowerShell 4, the versions of PowerShell prior to Core, those just came on the box, and God only knows how you build those things. Or even like what executables and binaries you would need to like make a fully running, version of PowerShell. Whereas with PowerShell Core, I can go to GitHub, I can pull down the release, I can build it, I have the binaries, I can just pop them on the machine, and I know what I'm getting. That's really the story behind that is that because that's the whole story behind really Habitat really. Like, so even on Linux, we're going through all this work to make sure that we know the exact version of zlib, the exact version of glibc. We're linking to that exact same version. Now linking works a little differently on Windows. We don't have ELF binaries, and we're not able to link that way, but we can control what we put on the path, and what when you hit PowerShell.exe, what actually gets run. Does that answer your question? Okay.
I forgot that one.
Yeah, it is, and that's cool too. Yeah. In fact, actually, so the interesting thing to create the PowerShell core plan, there was one thing that was like kind of off. So I was able to submit a PR to PowerShell, and that got accepted. So that's just I love that about PowerShell now. It's like the total community effort now. Pretty awesome. And yeah. So yes. So one thing that I didn't do was, so I gave you the vanilla no security. Isn't it nice that we can just be meet here as friends and run without security? So Habitat absolutely has a way of encrypting everything that it sends out on the wire. And so it has a whole key mechanism which you can create keys. You can partition your ring by service group and have different keys for different rings, so that every bit of configuration that goes over gets encrypted using those keys. One thing actually that you didn't really fully touch on this, but you mentioned the HAB user and the HAB password, and that kind of makes me think. So this is another thing that we haven't fully developed in Windows as opposed to Linux. So in Linux, when you start up a hook, you start up a service with a hook, I can start up that service and start it under the credentials of the HAB service user and HAB service group that you've specified. On Windows, we currently don't do that. That's another thing that before you actually go to production, you want to be able to start services under a particular identity. It's a little trickier. The reason why we haven't done that is it's, the process model on Windows is totally different from Linux, or different in many ways. So it's more difficult to do, but that is something that we're planning on having available. So the thing with hooks, so they can be a lot of different things. When we initially invoke a hook, so on Linux, we use you can put a shebang at the top. So if you want your hook to be a Python or Ruby, and as long as you've declared a dependency on the runtime that you want to target, you can put that shebang at the top, and it'll run whatever. I mean, so I guess conceivably, you could have you'd have to declare a dependency on like Chef, and actually there are internal efforts of some kind of skunkworks internal efforts of creating a Chef client plan. But you could imagine you take a dependency on a Chef client and have it consume your hook or a portion of your hook as a recipe. I could see that happening.
Yeah, that would basically.
Yeah, I mean, there's all sorts of ways that you can kind of bastardize. Yeah, I mean, from a technical point of view, as long as you have the right dependencies, and on Linux, put that shebang up there. Now on Windows, it will, when it invokes the hook, it's always going to invoke it through PowerShell. But let's say you wanted to do something in C#, and that just means you take a dependency on your C# application, then you just call out for that. But the initial bootstrapper would have to be PowerShell, even if it's just one line that calls a secondary one. Cool. Well, yeah. So as you notice in the plans that I showed you, you didn't see any plan that actually declared a dependency on PowerShell, right? So yeah, it is kind of hidden. So actually, in the guts of Habitat itself, when you there's two areas specifically. One is in the supervisor itself. So the supervisor, when you basically call hab start, there's code within Habitat's native, the Rust, Habitat is written in Rust. So in the Rust code for Habitat, we actually say, hey, go off and look for core/PowerShell, and pull that down. So basically, it kind of fools you, but under the covers, it's being used as a dependency, even though you can't see it in your plans. So does that answer your question though? I'm not sure if that was the question you really asked. Yeah. Oh, I see what you're saying. Oh, so that is interesting. So I guess what you would have to do now is this is similar to what we just talked about just a little bit ago, which is you'd have to declare. So like, as you know, like you can run Bash on Windows. You'd have to declare a dependency on that, which means somebody would have to build that dependency. Right now, there is no. We don't have a Habitat plan for Bash on Windows. That's certainly possible. And then Habitat would call PowerShell to do the initial invocation, and then you would probably just shell out basically in your PowerShell plan off to Bash. That's how I would see it happening. I mean, as we move forward, if that becomes a more popular desire, we could make that more native. But maybe so I may have crossed wires here. I guess you're talking about on Windows 10 that Bash, the Bash for. Oh, okay. So that's actually interesting. Like I don't even know how you would. I've never thought about it before, but I don't know off the top of my head how you would make that into a plan. I suppose it's possible, but I'm not sure. I'm thinking more of the kind of the Cygwin MSys variety of Bash. Like I could easily think of how you might package that up. Totally, yeah. I've So that's actually a good point. So right, yeah. So what we've done in the Habitat, the actual Habitat artifact, is we've created a new file called target. And so ideally, you could do things like cross compilation for Habitat, and so you could say, we don't have this yet, but I could imagine without incredible difficulty, I can imagine us being able to say, hey, build this and target Linux, even though I'm on Windows, or build this and target Windows, even though I'm on Linux, and it would actually build the heart, and it would give it a target of either Windows or Linux. I might be on Windows, and it would give it a target of Linux if I'm building the Bash and DCC and whatnot. That's right. As things stand for the foreseeable future, we're imagining if you build on whatever actual system you build on, that's what you'll get. Cross compilation isn't fully in our crosshairs right now, but it's absolutely a topic that's come up, and if enough people bring it up, I'm sure it'll get pushed up higher up the priority chain.
Actually, a related note is whether you get hopped into a PowerShell terminal or that or environment, or an Appsio on, whether side or not our version of the binary.
Right. Yeah. All right. Yeah.
So you talked a little bit about computers.
Yeah.
Is that really?
So you can think of, so there's really, well, in my mind, there's two key habitat scenarios where we would leverage containers. One is the studio, the actual build studio. So one of the challenges that we have on Windows is creating like a sanitized clean room system. Because even, so I mentioned, we clean up the path and we keep, just for sanity's sake, C Windows and C Windows System 32. But just by virtue of doing that, you don't really have isolation. Because I could have if I download the C++ 2013 redistributable, yeah, now all that stuff goes into System 32, and now I go to run my package on some other system that doesn't have that, and everything blows up. So if I could spin up a fresh container when I do my build, I can have more of a guarantee that my app will run at runtime if I know all of its dependencies are actual declared dependencies, not just happen to be floating around in Windows 32. So there's that side of the story, and then probably the more interesting side of the story is the supervisor level. So being able to actually deploy my application, so that the deployable artifact becomes basically a Docker container. Now it's important to note that Habitat is not, nor is it really in the business of trying to be a scheduler. But what we do want to do is we want to act nicely. So we want to, there's people today that are working to try and make Habitat and Kubernetes work nicely with one another. So you can kind of think of a world where you've got Habitat, Kubernetes, and Windows containers. So Kubernetes is trying to, I don't know where they are now exactly, to be honest. I know that there are efforts, at least, and maybe it actually does work with Windows containers, and so you could get that whole story working. Yeah. All right. Well, cool. I am super excited to actually this getting into people's hands, and if you're curious about if you want to keep tabs on how this is going or want to ask questions about it, just go to the Habitat website, habitat.sh, and there's links to a Slack channel and a forum, and so you can totally ask questions there. There's a Windows channel in that in Slack that you have. That's a great place to ask Windows specific stuff, but you can certainly ask Habitat general stuff there in the general channel as well. We hope that this will be awesome for running Windows applications. Thanks a lot.